Alright, we've talked about basic substitution. Now I want to give us some examples that are a little more complicated. This substitution involves a little bit more work. So we're solving a system. We have two equations. We know it's a system. And we're solving this system. We're trying to find a solution. And just like we've talked before, your solution should always be written as an ordered pair. So we know that our solution is going to look like this. We're solving for an ordered pair. We know that ordered pair is going to be x and y. So I'm going to go ahead and write out my different points so that I know what I'm solving for. And actually, let's move this up a little bit farther so we have a little bit more room right here. Okay. So I'm looking at this, and my goal is I'm always looking at this and saying, okay, which of these has a variable that's isolated that I can substitute into the other one? And I'm noticing that there is nothing here. This one is not solved for x and y, and this equation is not solved for x and y. When this happens, you need to rearrange one of the equations for a variable. So you need to rearrange for a variable to isolate a variable. Now, you don't need to write this down right now. I just want you to watch, and I want you to see why we should pick the variable that we pick. So I'm looking at these two examples, and I'm first just going to rearrange this one. It is easier to rearrange an equation for a variable that has a coefficient of 1 than one that has a coefficient that is greater than 1. And we're looking for a positive one. So I'm looking here, and this x has a positive 1 as a coefficient. This y has a negative 4 as a coefficient. This has a negative 3 as a coefficient. This has a negative 8. This is going to be the easiest, and I'm going to show you why. Let's rearrange this equation right now. I have 1x minus 4y equals 16. I'm looking for the equation that has a coefficient of positive 1. So that's a key point I want you to write down. Look for and rearrange for a positive 1 coefficient. If I were to solve this equation for this positive 1x, the only thing I need to get rid of is this minus 4y, and I would just have to plus 4y to the other side. And I'd be left with x equals 16 plus 4y. That's it. Now I have a variable isolated. I can put it here. Let's say if I used this equation and I tried to solve. So I need a little bit more room, so I'm going to do this down here. I have a negative 3x minus 8y equals negative 8. Neither of these have a coefficient of 1. So let's just solve for this y. Right? First, I'd have to bring over the 3x. These would cancel. I would get negative 8y equals negative 8 plus 3. Then I'd have to divide by negative 8. And I would get y equals positive 1 minus 3 over 8. Whoops, I forgot to put my x here. 3 over 8 x. This is a lot more work than this. If we just look for a coefficient that has a positive 1, it is a lot easier. So I'm going to erase this now, but I want you to see why that was easier. I'm going to give us back some more room. So always look for the equation that has a positive 1 coefficient and rearrange for that number. So now I've rearranged x minus 4y equals 16. I've rearranged that into x equals 16 plus 4. So I'm going to write that here. X equals 16 plus 4y. And I still have my second equation. I'm going to write that under y. All right. Now, just like before, x equals 16 plus 4y. I can substitute this whole thing in for x, the whole thing. So I'm going to rewrite this. Negative 3, and when I put my parentheses in, give yourself a little bit of room. Negative 3x minus 8y equals negative 8. x is 16 plus 4y. I'm going to write that whole thing in here, 16 plus 4y. I want you to notice that I wrote this entire thing in for x. There is no x's here. X was replaced by this whole thing. And now we can solve for y. You should see distributing here, so let's go ahead and do that. A negative 3 times 16 is negative 48. A negative 3 times 4y is a negative 12y. I'm going to bring down my negative 8y, and it all equals negative 8. We should now see that there's some terms we can combine. I'm going to combine my negative 12y and my negative 8y. Bring down my negative 48. Negative 12 plus negative 8 gives me a negative 20y, and that whole thing equals negative 8. Now this is a two-step equation. I need to get y by itself. So first I'm going to get rid of my my negative 48 by adding 48 to both sides. These cancel out. I'm left with negative 20y equals negative 8 plus 48 is a positive 40. I have negative 20 times y equals 40. To undo times negative 20, I'm going to divide by negative 20. We're running out of room. These cancel, and I'm left with y. Let's write that a little bit above. I'm left with y equals 40 divided by negative 20 is negative 2. I think that y is negative 2. Now I have y. I can still plug y into this equation. So I'm going to rewrite this. X equals 16 plus 4 parentheses. I think y is negative 2, so I'm going to put negative 2 in for y. Let's simplify. Bring down my 16. 4 times negative 2 is negative 8. And 16 minus 8 is 8. Now remember, whenever you're solving, before you write your answer out, you should check. And let's actually move our check over a little bit so we have a little bit more room. In these kinds of problems where you had to rearrange first, it's especially important to check because you could have made a mistake up here and you won't notice it until you check at the very end. So when you're checking, especially when you rearrange, remember you're always using the original equations. So I'm going to write out these two equations. X minus 4y equals 16. And my second equation, negative 3x minus 8y equals negative 8. And let's see if it works. I had a parentheses in for x, minus 4 times y equals 16. Well, x was 8, and y was negative 2. I'm going to bring down my 8. Negative 4 times a negative 2 is a positive 8. And 8 plus 8 equals 16, and 16 equals 16. It works. Let's check with our second equation. I have a negative 3 times x, which I think is 8, minus 8 times negative 2. Negative 3 times 8 is negative 24. Negative 8 times a negative 2 is a positive 16. And negative 24 plus 16 is negative 8. Does negative 8 equal negative 8? Yes. The check works. I checked it in both equations. My x and my y work, so I'm going to write my solution. X is 8, and y is negative 2. Here is your solution. Let's do a couple more examples of this because this one's a little bit challenging. Let's do another example. Now remember our key point. We're looking at this and we're saying, okay, are either of these have a variable isolated? No. And remember that we're looking for a coefficient of positive 1. So which of these has a coefficient of positive 1? Well, this one has a coefficient of 2, and I know there's a 1 here, but this has a coefficient of negative 1, so that won't work. This one has a coefficient of 3, and oh, here, a positive 1. So I'm going to rearrange this equation. So if I want to get this positive 1y by itself, I need to get rid of this 3x. So I'm going to minus 3x on both sides. These cancel out. I'm going to bring down my y equals negative 6 and negative 3x aren't like terms, so I'm just going to rewrite negative 6 minus 3x. Here is the equation that now is isolated. So I'm going to go ahead and I'm going to solve for x. I'm going to solve for y, and I'm going to check my answer. Oh, and I also forgot to write out at the top my solution so that I remember to solve for that. So we've solved for y. So let's write that under here. Y equals negative 6 minus 3x. And I'm going to use this equation to solve for x. 2x minus y equals 6. All right. Remember that this is y, this whole thing. And I can put this whole thing in for y. So I'm going to rewrite this. 2x minus parentheses, leave yourself some room, equals 6. Inside my parentheses, I'm going to put this whole thing, negative 6 minus 3x. Now we should see that there's some distributing that we can do. So I'm going to bring down my 2x. This always gets us tripped up right here when there's this minus sign outside this parentheses. But remember that there's an invisible 1 right here. So it's like we're distributing a negative 1. So negative 1 times negative 6 is positive 6. Negative 1 times negative 3 is positive 3x. And the whole thing equals 6. You should now notice that we have some terms we can combine. 3 and 2 give you 5x plus 6 equals 6. I'm going to try to solve for x, so first I'm going to get rid of this plus 6. These cancel. I'm left with 5x equals 0. And 5 times x, so to undo times x, I'm going to divide by 5. So x equals 0. Now I have my x, I think it's 0. I still need to solve for y. So I'm going to say, okay, y equals negative 6 minus 3, and instead of an x, I'm going to put 0. Let's see what we get. Y equals negative 6 minus 3 times 0 is 0. Well, what is negative 6 minus 0? That is negative 6. So I think that y is negative 6 and x is 0. But remember, I should check. And when you check, you should be using your original equations, not this one you rearranged. So I'm going to just rewrite what I have here. 2x minus y equals 6. And 3x plus y equals negative 6. I'm going to go ahead and substitute in my values. So the value of x that I found was 0, minus y, which I think is negative 6. 2 times 0 is 0. And then I have minus negative 6. Now, this is a little bit tricky, but remember when you have two negatives, subtracting a negative is like adding. And 0 plus 6 is just 6. It works. Let's try the next one. 3 times x, which I think is 0, plus y, which I think is negative 6. 3 times 0 is 0, plus negative 6. And 0 plus negative 6 is negative 6. My check works. So my solution is that x is 0 and that y is negative 6. All right, we're going to do one more example, and then there's a few practice problems. So we'll do one more, example 8. Again, you're solving a system. We know that our solution is going to be something x comma y, something comma something. So I'm looking here, and I'm looking for one of these equations that has a variable isolated, and I don't see it. So I know that right now I need to rearrange. You're now going to look and say, okay, do either of these equations have a coefficient of positive 1? I have a positive 4, that won't work. I have a negative 2, that won't work. I have a positive 1 right here, that'll work. I have a negative 1, that won't work. So I'm going to rearrange this for x. I'm going to do that right up here. So I'm going to rewrite, I have x minus 1y equals negative 1. I'm trying to solve for a positive 1, so I'm going to solve for this positive 1x. I have to get rid of minus 1x. I'm going to add, minus 1y. So I'm going to add 1y to both sides. Bring down my x. These are not like terms, so I have negative 1 plus 1y. So I know that x is going to be equal to negative 1 plus 1y. I'm going to rewrite my other equation here. 4y minus 2x equals 6. Alright, so I have this. This whole thing equals x. I'm going to put this whole thing in for x. So that's going to look like 4y minus 2, big parentheses, equals 6. So let's substitute it in. For x, I'm going to put this whole thing, negative 1 plus 1y. Oh, easy way to check that you did this right is that there should be no more x's here. The x has been replaced. This whole thing has replaced the x with this. Now we need to simplify. Negative 2 times a negative 1 is a positive 2. Negative 2 times a positive 1y is a negative 2y. And the whole thing equals 6. I see some like terms. I see a negative 2y and I see a 4y. When I combine those, I get 2y plus 2 equals 6. I want to solve for y. So first I'm going to undo my plus 2. And I get 2y equals 4. I'm going to rewrite this up here because we ran out of room. I have 2y equals 4. Now to get my y alone, I know that we're multiplying by 2. So I'm going to divide by 2 on both sides, and I get that y equals 2. Okay, I think that y is 2. Let's make sure. Let's see about x. Alright, if I know that x is going to be equal to negative 1 plus 1y, let's see what y would be. Negative 1 plus 1 times y, which was 2. Now remember, you don't need this 1 because 1 times 2 is just 2. So I'm going to rewrite negative 1 plus 2 and negative 1 plus 2 is 1. So I think that x is 1. I think that y is 2. Before we write our solution, let's check using our original two equations. So I had 4y minus 2x equals 6. And then I had x minus y equals negative 1. Well, I think that y is 2. Circle that so it's a little bit easier to see. I think that y is 2, and I think that x is negative 1. I think y is 2, so I'm going to put a 2 in for y. Minus 2, I think that x is positive 1. 4 times 2 is 8. Negative 2 times 1 is negative 2. 8 minus 2 is 6. So 6 equals 6. It works. Let's try our second one. X was 1 minus y, which was positive 2. 1 minus 2 is negative 1. And negative 1 equals negative 1. It works. So my solution works. So my solution is 1, comma, 2. If you are still confused or you're unsure what to do, before you try the practice, I would go back and re-watch this video and pay particular attention to every step that we're taking and really listen close to the words. So here are 3 practice problems. Pause the video, try the practice problems. You should know before you resume and press play to check your answers that your answers are right based on your check. Make sure that for every single one of these practice, you have a solution that is in an ordered pair. If you solve for x and y but don't put it in an ordered pair, you are incorrect. So go ahead and pause your video now, try the practice problems, and then press start when you're ready. Alright. You should have had number 1, 3, 10, and number 2, negative 3, 8, and this third one should have been no solution. So I'm sure you got stuck on this one. I want to talk about this one because it's a little bit tricky. We should have rearranged one of our equations, and we're looking for a coefficient of positive 1. And you'll notice here that there is none. There's a negative 10, there's a 4, there's a negative 5, and a 2. So what I'm going to do first is I'm just going to rearrange this bottom one for y. You should know how to do this because we talked about this in the previous unit. So I'm going to rearrange for y. So first I'm going to get rid of my negative 5x. So I have 2y equals negative 2 plus 5x. Then I'm going to get rid of my 2. So this equation rearranged is y equals negative 2 divided by 2 is a negative 1 plus 5 over 2x. Now, let's go out and do this problem. We're going to solve for x, we're going to solve for y, and we're going to check. Okay? We know that y is going to be equal to negative 1 plus 5 over 2x. We know that x is going to be that other equation, negative 10x plus 4y is going to be equal to 6. So let's go ahead and let's rewrite. We have, and we're going to run into space a little bit, so if you have this copied down, I'm going to re-erase this word so we have a little bit more room. And I'll rewrite my equation up here so that we still have it. We know that this equation right here turned into y equals negative 1 plus 5 over 2x. Let's erase this arrow. Okay. So let's go ahead and plug it in. I have a negative 10x plus 4, big parentheses, because we're going to put this whole thing in, equals 6. I'm going to put in negative 1 plus 5 over 2x. Now I'm going to simplify. Bring down my negative 10x. Positive 4 times a negative 1 is a negative 4. A positive 4 times a positive 5 over 2x is 10x. And it equals 6. Now I see that there's some terms I can combine. I combine this negative 10 with this positive 10. And that gives me 0. I'm going to bring down my minus 4 equals 6. 0 minus 4 is negative 4. I have negative 4 equals 6. Is this a true statement? This is not true. This does not work. When this happens, your answer is going to be no solution. But before you make sure that you need to make sure that you didn't do anything wrong. If the answer is no solution, the line should have the same slope. The line should have same slope. So, if I'm looking at this equation, and I rearrange this so it's in proper y equals mx plus b form, I would see that my equation is really 5 over 2x minus 1, and that my slope is 5 over 2. That's my m. What we need to do in order to check that it's actually no solution, that the answer is no solution, is we need to rearrange this equation and see if we get 5 over 2 as a slope. So that is what I'm going to write underneath my check. I'm going to rearrange this equation. So I have a negative 10x plus 4y equals 6. Okay. I'm going to rearrange this equation so that it looks like y equals mx plus b. First I'm going to bring over my 10 by adding 10x to both sides. These cancel out. I'm left with 4y is equal to 6 plus 10x. I still need to isolate my y, so I'm going to divide by 4. These cancel, and I'm left with y equals 6 over 4, and I'm going to rewrite that here because I know that's my y-intercept, and 10 x divided by 4, which can be reduced to 5 halves x. If you don't believe me, do 10 over 4 in your calculator and reduce it, and you'll get 5 halves x. You'll see that this is your m in this equation, and your m in this equation are the same. Since these two equations have the same slope, the same end, there is no solution. Now, we don't have a graph here, but I want to just quickly show you why that is. If they have the same slope but different y-intercepts, that means that they will never cross each other. Because if this line crosses at a -1, and let's say this is its slope, and this line crosses at 6 over 4, which is a little over 1, and it crosses up here, these two lines are straight. They're never going to touch each other. They're going to keep going up and over, rising and running, or going at the same rate of change every time, and they will never catch up to each other. So that is why it is no solution. If you are still confused or are having trouble, go back and re-watch some of the examples and try the examples again.